Let's have a look at how we can reference data in our code, what we can use to refer to some other location in memory. The thing I'm talking about is called a pointer. Pointers are used to refer to values that exist somewhere else in memory. The value stored inside a pointer is then an address. It is a location in memory itself. It says where you'll find the value is over here. And we can picture that like a pointer. Stick your hand out, point your finger in a direction. That's the way we think of a pointer, something that points to something. It's a visual metaphor, this name. So we can picture that like this. Imagine we've got memory laid out like this. Each of these boxes represents 32 bits worth of data, and in this case our pointers are 32 bits. This address here might be the address 0x100, which is integer value 256. That value there, or that location in memory, has that address. And we've got different addresses for each of these 32 bits, based on an offset of 32 bits for each one. So this is address 320. At that location, I might have the variable a stored. So a is this location in memory. So we can picture that is our variable a. I might have a pointer variable here, designated by this, and this pointer variable has its own address, so it's located in this space in memory. The key bit is the value inside this variable is considered to be the location in memory of something that we care about. In this case, this is the location of this variable here. See, we see 0x140 is the address of that block of memory. So we can use this pointer to access this block of memory. The idea being we can picture the pointer as being a variable that points to something else. The value that you want is over there. How do we get these pointers, the actual values that we want, whereabouts things are in memory? We can use the address of operator to get a pointer for an existing value or existing variable. So here in C++, we use the ampersand. So P equals ampersand variable says, get me the address of this variable and store that in the pointer P. Let's picture that again. In this case here, we would say that the address of A would return the value 0x140, which is the location of this in memory. We can use the dereference operator to follow a pointer. This allows you to read a value from the thing that the pointer points to. So if I say x is equal to star p, that means dereference the pointer p and get me the value. Follow the pointer, read the value that you find. If we did the same thing here, right line star p, get the value of p, okay, it's an address, go to that address, read the value that's there. So in this case, if we did star p, it would return the value from the variable a. How come? Well, star p would be read the value of p. The value of p is 140, 0x140. Star p would then be, okay, well I go to that address, okay, that's here, and I read this value. So it's whatever value is stored inside here. This just in this case happens to be the value that is also inside this variable a. Similarly, we can put that dereference operator on the left-hand side of an assignment. That means that this becomes the destination where we store the value. And it's the same thing. Follow the pointer and store the value at that location. In this case, if I did star p equals 10, then that would mean read the value of p, which is 140, follow that pointer, or go to that location in memory, that's this location here, and store the value 10 there. So we would be storing 10 inside here. This line of code would change the value of variable a, even though it doesn't mention a in the code there. That's because the variable p points to the same location in memory where a is located. Pointers make a whole range of new things possible. Let's have a quick look at that code in action just to see how it works. So I can declare two variables, an integer to store a, and p, which is a pointer to an integer. The star here indicates this is a pointer, and this tells me that this pointer will point to a value that we expect to be an integer. We can assign each of these values. So I've given A the value 10, and P has been given the address of variable A. We can write out the values, both the value we read by following the pointer and the value out of the variable itself, just to check these. When I run this, we can see that we can access the value of A with the value of 10, and when we follow P, we get the value 10 as well. Changing the value of A means that the value that P points to is changing, because P is storing the address of variable A. Changing the value that P points to also changes the value in the variable A, because P points to the variable A, the location in memory where A is stored. I can create a new variable, and we can then assign that variable a default value, and down here we can assign P to refer to that location in memory. Notice now that P is referring to the value in variable B, not the value in variable A. So the pointer can be moved from pointing to from one thing to pointing to something entirely different. It's very flexible. Its location in memory doesn't change, but the value we store in there can change, so it can point to different things over its lifetime. That gives us a bit of a quick start with pointers. Now at the moment, we're only using this to point to values inside our code, or inside variables that we've already created. This is useful because sometimes we can create flexible options, and this is what we've been using when we've done pass by reference. Pass by reference just uses pointers in the background. It's just managed for you by the compiler. What we're going to be able to do with pointers ourselves is to set up things like dynamic relationships, where you connect things together by referring to the other party rather than copying and embedding all of that other party's data within your entity. But we can also use it for working with dynamic memory. Let's have a look at that next.